Every diagram of the solar system you have ever seen told you the same comfortable thing. It ends at Pluto. 8 planets, a few neat rings, a last cold dot, and then nothing. But here is what those diagrams left off. The planets occupy the first 30 units of a structure that runs to 100,000. If you drew the solar system honestly, to scale, every planet, including the one beneath your feet, would vanish into a single bright speck at the center of the page, and the rest of the sheet, almost all of it, would be the part nobody draws. Out there, past the last planet, past the edge of the sun's wind, is a vast spherical shell of frozen comets, so enormous it reaches a third of the way to the next star. And it is the largest thing the sun owns, and no human telescope has ever seen it. And it is not even the edge. So if the solar system does not end at Pluto, and does not end at the Oort Cloud, where does it actually end, and what is waiting in the dark just past it? Get comfortable. Hit subscribe if you are new here, because by the end of this, the word edge is going to stop meaning what you always thought it meant. Now, let us slowly ease into this. Part 1. The map you were given. Somewhere in your memory, there is a picture of the solar system. You did not choose it. Someone handed it to you, probably when you were very young, probably on a poster taped to a classroom wall or a glossy page in a school book, and it has stayed with you ever since because it is simple and it is tidy and it feels complete. In that picture, the sun sits at the center, a yellow circle, sometimes with little drawn flames curling off the edge. Around it run a set of neat concentric rings, and on each ring sits a planet. Mercury, Venus, Earth, Mars, then the gap, then the 4 giants, Jupiter and Saturn and Uranus and Neptune. And at the far edge, depending on how old your poster was, either nothing at all or a small cold dot named Pluto. And past that last dot, the picture simply stops. The page ends, the poster ends, the coloured ink runs out, and without ever quite saying so, the picture tells you something. It tells you that the solar system ends there too, right at the edge of the paper, and that beyond it is empty black space, a clean and total nothing, stretching all the way to the next star. Tonight I want to take that picture apart. Not because it is a lie, exactly. The sun is real. The planets are real, and they really do orbit in those rings, more or less. The picture is not false. It is something subtler than false. It is a crop. It is a photograph of a vast, dark room that shows you only the lamp burning in the middle and a few small objects sitting close to the light, and then crops away everything else, the whole rest of the room, and quietly labels the cropped version complete. The planets are real. But the planets are not the solar system. The planets are a thin film of debris orbiting close to the fire, and the true extent of the sun's domain reaches outwards so much farther than that last drawn ring that if you redrew the poster honestly, to scale, every planet, including the one you are sitting on right now, would shrink and shrink until it vanished into a single bright pinprick at the very center of the page, and all the rest of the paper, very nearly the entire sheet, edge to edge, would be the part that nobody ever draws. To feel how much got cropped away, you need one number, just one, and once you have it, the rest of the night will unfold from it. The number is the astronomical unit. 1 astronomical unit is the distance from the Earth to the Sunday. It is about 93 million miles, about 150 million kilometers. It is already a distance the human mind cannot really hold. If you could drive it at highway speed without ever stopping, it would take you well over 100 years to cross a single astronomical unit. Light itself, the fastest thing the universe permits, the thing nothing can outrun, takes 8 minutes and 20 seconds to cross that 1 unit. The sunlight on your skin left the sun 8 minutes ago, We will measure everything tonight in those units. Every distance, every layer, every boundary, because the astronomical unit is the only ruler long enough for the journey we are about to take, and because watching that single number climb higher and higher is in a real sense the whole story. So let us start the count. On the ruler of astronomical units, the Earth orbits at 1, Mars orbits at about 1.5. Jupiter, the largest planet, the giant, orbits at about 5. Saturn, with its rings, at about 9.5. Uranus, at about 19. And Neptune, the last of the true planets, the outermost world, the deep blue giant, orbits at about 30 astronomical units from the Sunday. 30. Hold that number. 30 is the edge of the planets. 30 is where the map you were given runs out of ink and the poster ends. And here is the quiet, enormous fact that the whole night turns on. The sun's reach does not stop at 30. It does not stop at 100. It does not stop at 1000. The sun's gravitational grip extends outward to something close to 100,000 astronomical units, and quite possibly farther still. Let that sit beside the other number. The planets occupy the first 30 units of a structure that runs to 100,000. Do the arithmetic on that, and it tells you something almost unbelievable. The picture in your memory, the tidy one with the neat rings, the one that has stood in for the solar system your entire life, shows you roughly the inner 0.03% of the thing it claims to depict. It crops away the other 99.97%. And it hands you the crop and calls it the whole. So the question for tonight is the one printed in the title, and I want you to hear it not as a poetic question, not as a mood, but as a literal, answerable question, the kind that has a real answer made of real things. What hides beyond the Oort Cloud? To get to an answer, we first have to travel out to the Oort Cloud itself, and that means travelling out through everything the map left off, layer by patient layer, in their true order, watching that astronomical unit number climb the entire way. And here is the thing I want to warn you about before we begin, because it is the shape of the whole journey. Every single layer we pass through is going to do the same thing to you. Every one of them is going to feel, when you reach it, like an edge, like the place where the solar system finally, genuinely ends. And then we are going to keep going, and the edge will dissolve behind us, soften, lose its meaning, and a new boundary will rise ahead, farther out, and that one too will feel like the end. It is going to happen 4 separate times, 4 different edges, 4 different places, and each one has a genuine, defensible claim to being the true boundary of the solar system. And they sit so unthinkably far apart from one another that you could take the entire distance from the Sun all the way out to Neptune, the whole span of the planets, and lay it end to end inside the gap between 2 of those edges more than 3,000 times over before you filled it. By the time we reach the last of the 4, the word edge is going to have quietly stopped meaning what you have always assumed it means. And the thing that lies past it, out there in the dark, is not the clean nothing the poster promised you. It is something with a structure of its own, and a kind of weather, and even visitors that come and go. But all of that is ahead of us, and we will get there slowly, because slowly is the only honest way to cross a distance like this. For now, simply hold the picture in your mind. The Sunday, the neat rings, the planets in their order, the last small cold dot, and the black emptiness drawn past it. That is the map you were given. Keep it carefully, keep it close, because we are going to come back to it at the very end of the night, and the most surprising thing about that map is not going to be what it got wrong. It is going to be what it left out, and how much of it there turned out to be. Part 2. Past the Last Planet. We begin in earnest at Neptune, 30 astronomical units out, because Neptune is where the map you were given runs out of ink, and the imagination is left without a guide. It is worth standing at Neptune for a moment before we go on, because it is a genuinely strange and beautiful world, and most people never give it a thought. Neptune is a deep, vivid blue, the color of deep ocean water, and the blue comes from methane in its atmosphere, absorbing the red light and throwing back the blue. It is the windiest place in the entire solar system. Storms tear across Neptune at speeds that on Earth would be supersonic, faster than the speed of sound, and they do this on a world so far from the Sun that the sunlight reaching it is about 1,000 times fainter than the sunlight reaching Earth. Neptune is dim and cold and ferociously active, and it orbits so far out that a single Neptunian year, one trip around the Sun, lasts about 165 Earth years. Neptune was discovered in 1846, and since its discovery, it has completed only one full orbit. It returned to its starting point for the first time since we found it in the year 2011. For most of the century and a half after that discovery, the story we told ourselves was clean and simple. Neptune was the doorman. Neptune was the last planet, the final world, the outpost. Cross Neptune's orbit, and you had left the solar system behind you. The map agreed. The poster agreed. Neptune, or sometimes Pluto just beyond it, was the end. But cross Neptune's orbit, actually go out there past 30 astronomical units, and you do not find emptiness. You do not find the clean black nothing. You find a ring, a vast, broad, flattened ring of icy bodies circling the Sun in roughly the same plane that the planets orbit in, beginning right around Neptune's orbit at 30 units, and stretching outward to roughly 50. This is the Kuiper Belt, and it is worth pausing hard on that word, belt, because the word invites you to picture the wrong thing entirely. It invites you to picture the asteroid belt, the famous one between Mars and Jupiter, the one that films and games love to send spaceships diving and weaving through, dodging tumbling boulders at every turn. Erase that picture. The Kuiper Belt is nothing like it. The Kuiper Belt is enormous, vastly larger than the asteroid belt, and it is overwhelmingly empty. If you were standing on one of its bodies, you would almost certainly not be able to see another one anywhere in your sky. And its members are not rock, they are ice. Frozen water, frozen methane, frozen ammonia, frozen nitrogen, the leftover building blocks of the outer solar system, material that was present when the planets formed, but that never got swept up into a planet, that simply stayed out there in the cold and the dark, drifting and orbiting, almost unchanged, for 4.5 billion years. The Kuiper Belt is a kind of frozen archive. It is the construction site of the outer solar system, abandoned, with the unused materials still lying exactly where they were left. And here is the first thing the map you were given got wrong, and it got it wrong not by leaving something out, but by promoting something falsely, Pluto. The small cold dot at the very edge of the poster, Pluto was discovered in 1930, and for 76 years it was taught, all over the world, as the 9th planet, and generations of schoolchildren learned its name as the answer to the question of where the solar system ends. But Pluto is not a lonely final world standing guard at the border. Pluto is a member of the Kuiper Belt. It orbits at an average distance of about 39.5 astronomical units, squarely inside the belt, and it has company. A great deal of company. There is Eris, a body almost exactly the same size as Pluto, discovered far out in the same region, and it was the discovery of Eris that finally forced astronomers to face the question honestly. If Pluto is a planet, then so is Eris, and so are the others, and the word planet stops meaning anything useful. There is Haumea, a genuinely bizarre world that spins so fast, completing a full rotation in under 4 hours, that its own rotation has stretched it into the shape of an egg, or a flattened rugby ball. There is Makemake. And beyond those few named worlds, there are thousands upon thousands of smaller icy bodies already catalogued, and certainly very many more still waiting in the dark to be found. Pluto was never the last planet. Pluto was simply our first clear look at the next layer out, the first Kuiper Belt object, large and bright enough to be spotted. We found the doorway, and for 76 years we mistook it for the wall. The Kuiper Belt is also the home, the birthplace, of most of the comets you have ever heard of. Not all comets. The distinction is going to matter enormously later tonight, so I am going to ask you to hold on to it from here on. There are two great families of comets, and they come from two completely different places. The Kuiper Belt is the source of the first family, the short-period comets, the ones that return on human timescales, that come back every few decades or every couple of centuries, faithfully, like clockwork. Halley's Comet is the most famous of these. Halley's returns roughly every 76 years, which means a single human being, if they are lucky with the timing of their birth, might see it twice in a long life, once as a child and once near the end. Comet 67P, the strange rubber duck-shaped comet that the Rosetta spacecraft chased across the solar system and actually landed a probe on, is another of these short-period comets. All of them are pieces of the Kuiper Belt, or of the region just beyond it, that something long ago nudged inward, and now they fall toward the Sun on long looping orbits, warm up, grow their bright glowing tails, swing hard around the Sun, and retreat back out toward the cold, and then return again and again on a schedule. But the belt holds a genuine mystery, and it is the first real puzzle of our journey outward, so let us not rush past it. As you move outward through the Kuiper Belt, carefully counting the icy bodies as you go, the count behaves itself, holds reasonably steady for a while. And then, at around 48 astronomical units, the count does not do what every reasonable expectation says it should do. It does not gently taper, does not softly thin out into the dark the way a thinning thing should. It drops, abruptly, sharply, almost as though some great hand had swept the region beyond clean. Astronomers call this feature the Kuiper Cliff, and the cliff was a real surprise when it was found, because every model we have of how the solar system formed predicts a gradual fade at the outer Kuiper Belt, a soft and gentle thinning, not a cliff edge. Something made that edge sharp. Perhaps a massive body passed through the region in the distant past and gravitationally scattered the objects that ought to be sitting there now. Perhaps the original disk of material that built the solar system simply had a true outer edge, and the Kuiper Cliff is us looking straight at it. We genuinely, honestly do not know. And I want you to notice where we are standing when we hit this first unsolved mystery. We are barely past Neptune. We are at 48 astronomical units, which sounds far and is far, and yet it is still only the inner 300ths of 1% of the way out. We have barely left the porch, and we have already found something the textbooks cannot fully explain. Stand at the Kuiper Cliff a moment, and look back the way we came. The Sun, from out here, is still clearly the Sunday. It has shrunk. It is a smaller disk than the warm wide circle you know from Earth, but it is still unmistakably a disk, still bright enough that you could read by its light, still obviously the master of this place. Behind you, sunward, are all the planets, every one of them, and gathered among them is all of human history, every map and poster and schoolbook ever printed, every person who has ever lived, all of it folded into the inner 48 units. Ahead of you is the dark, and the temptation, standing at the lip of something called a cliff, is overwhelming. It is almost irresistible to believe that you have arrived at the edge of something, that this is the boundary. But you have not, and it is not. The Kuiper Belt is not the edge of the solar system. The Kuiper Belt is the first layer, the innermost of the layers the map left off. And the next layer out does not behave like a belt at all. The next thing we find does not orbit in a tidy ring. It behaves, every object in it, like something that has been picked up and thrown. Part 3. the things that never come home. If the Kuiper Belt is a tidy ring, a flat and orderly archive, then the next thing we encounter as we move outward is what happens when that tidiness shatters. Astronomers call this region the scattered disk, and the name is well chosen, exactly chosen, because the objects out here look precisely as though they have been scattered, flung, thrown outward by some force, and abandoned on wild, stretched, steeply tilted orbits that no longer lie flat in the calm plane of the planets. The scattered disk overlaps the outer Kuiper Belt and reaches far beyond it, and the difference is not where the objects are but how they move. The likely culprit, the hand that did the throwing, is Neptune itself. Early in the solar system's history, when everything was younger and more crowded and far more chaotic than the orderly clockwork we see today, the giant planets shifted and migrated, and Neptune in particular swept outward through this region, and its gravity flung a whole population of icy bodies onto these long, elongated, tilted paths. And they have been riding those paths ever since, for billions of years, frozen records of an ancient violence. Take Eris, the body almost the size of Pluto that we met a moment ago. Eris does not keep politely to a belt. Its orbit carries it from somewhere near the Kuiper Belt outward to past 90 astronomical units, 3 full times Neptune's distance from the Sun, before the orbit turns and the long fallback begins. An object on the scattered disk spends the overwhelming majority of its enormously long year far out in the deep cold, and only briefly, only near the closest point of its stretched orbit, does it come anywhere near the realm of the planets at all. And then there is Sedna. I want to slow right down for Sedna. I want us to give it real time, because Sedna is the single object that first told astronomers, clearly and undeniably, that the solar system had another whole layer they had not yet accounted for. Sedna was discovered in the year 2003. It is a distant, reddish world, somewhat smaller than Pluto, and its orbit, when astronomers worked it out, was so extreme that it simply did not fit into any category that existed at the time. It broke the filing system. Here is the precise problem that Sedna posed, and I want to lay it out carefully because the mystery is in the specific numbers. Every orbit has a near point and a far point. The closest that Sedna ever comes to the Sun, the near point of its long orbit, is about 76 astronomical units. 76. Sit with that for a moment against everything we have already covered. 76 is already far beyond Neptune at 30. It is far beyond the Kuiper Cliff at 48. Sedna, at its very closest approach, at the warmest and most sunward moment of its entire orbit, is still well outside everything we have so far called the solar system. And the far point of Sedna's orbit, the most distant it ever travels, is out around 900 astronomical units. A single orbit of Sedna, one complete Sedna year, takes something on the order of 11,000 Earth years to finish. The last time Sedna was at the point in its orbit it occupies today, human beings had not yet invented agriculture. Cities did not exist. Writing did not exist. Sedna has made perhaps a third of one orbit since the end of the last ice age. Now, hold those two numbers up together, the 76 and the 30, because the gap between them is the whole mystery. Sedna's closest approach to the Sun is 76 astronomical units. Neptune, the great scatterer, the hand that flung the scattered disk, orbits at 30, and here is the problem that this creates. Neptune's gravity cannot reach a body whose closest approach is 76. It is not close enough. For Neptune to have thrown an object onto its present orbit, that object has to, at some point, come reasonably near Neptune, has to pass through Neptune's gravitational reach. Sedna never does. Sedna never comes close enough to Neptune, or to any planet, for any planet to have placed it where it is, and yet Sedna is unmistakably bound to the Sunday. It is unmistakably orbiting. It is unmistakably a member of the solar system. So something put Sedna onto that strange, detached, far-flung orbit, something with real gravitational muscle, and it was not Neptune, and it was not any planet we know of. This is what makes Sedna so important. Sedna's orbit is a fingerprint left behind at the scene, and the fingerprint does not match anyone we know to be in the room. It points outward. It points to a population and a process that lie beyond the planets entirely. The leading explanations all reach out into the deep outer dark for an answer. Perhaps, long ago, another star passed close enough to the Sun that its gravity lifted and detached Sedna's orbit, pulling its near point up and away from the planets. Perhaps the Sun was born, as most stars are, inside a crowded cluster of sibling stars, and one of those siblings did the lifting before the cluster drifted apart and scattered into the galaxy. Perhaps there is something massive, something planet-sized, still out there right now, unseen, that we have simply not yet found, and its gravity-shaped Sedna. We will return to every one of those possibilities before the night is done. For now, the point is only this. Sedna is a body whose very orbit is testimony, and the testimony says that the solar system does not end where the planets end. It says there is more, much more, farther out. It is worth dwelling for a moment on what a place like Sedna actually is, on what it would be to stand there, because the scattered disk and the detached objects are not just orbits on a diagram. They are real worlds, frozen and dark. On Sedna, at its far point, 900 astronomical units out, the Sun would give almost nothing. It would be a fierce, bright point, the brightest thing in the sky, by far, but it would be a point, not a disk, and the light it cast would be something like the light of a full moon on Earth, perhaps a little more. You could see by it. You could not be warmed by it. The surface temperature out there hovers only a few tens of degrees above absolute zero, the absolute floor of cold, the temperature at which atoms themselves very nearly stop moving. Sedna's reddish colour is thought to come from a kind of slow chemistry, organic compounds called tholins, built up over billions of years as the faint trickle of radiation works on the frozen surface. It is a world that has been sitting in that deep cold, doing that slow chemistry, riding that enormous orbit, since long before complex life existed on Earth, and it will go on doing it long after. And Sedna, the astronomers now strongly suspect, is not a single oddity, it is not a one-of-a-kind freak. It is most likely the first visible member, the brightest and closest example of a whole population of bodies on these detached, far-flung orbits, a population whose true home is far beyond the Kuiper Belt, and whose members only rarely, and only a few of them, dip close enough to the Sun for our telescopes to catch them at all. Sedna is the one we can see. Behind it, in the dark, the reasoning says there should be very many more, an entire detached population that we are only beginning to glimpse the edge of. Each new object found out there on a Sedna-like orbit tightens the case, and the case points the same direction every time. It points outward to a process and a population beyond the planets. And notice that with Sedna, the entire character of the journey has quietly changed. Up to this point, travelling from Neptune to the Kuiper Belt to the scattered disk, we have been moving through structures that still orbit, broadly, in the plane of the planets. Structures shaped like rings and disks, flattened things, structures that still feel like natural extensions of the flat, familiar map in your memory. Sedna breaks that completely. Sedna, with its detached orbit and its impossible near point, is the first hard hint that beyond the disk-shaped solar system there lies a different solar system, vastly larger and not shaped like a disk at all. But before we can reach that larger structure, we have to pass through one final boundary. And this next one is the boundary that fooled us the longest, the one that even today, even now, many people and many maps and many textbooks still confidently call the true edge of the solar system. It is the place where the sun's wind finally dies. Part 4. The edge of the wind. The sun is not a quiet object. From the surface of the earth it can look serene, a steady, untroubled disk, the calmest-looking thing in the sky. That serenity is an illusion of distance. The sun is not calm at all. The sun is a constant, roaring, outward gale. It is continuously blowing a wind off its surface in every direction at once, a steady stream of charged particles, mostly protons and electrons, flung outward into space at hundreds of kilometers every second. We call it the solar wind, and there is nothing occasional about it. It never stops. It has never stopped. The Earth sits inside this wind and always has. Every planet sits inside it. The solar wind streams past all of them, every second of every day, a permanent invisible weather blowing out from the star. And that ceaseless wind does something profound, something that shapes the entire question we are chasing tonight. As the solar wind streams outward, it pushes. It pushes against the thin gas that fills the space between the stars. And by pushing continuously, for billions of years, it clears a space for itself. It hollows out a cavity. It inflates an enormous bubble, with the sun burning at the center of it and every single planet held deep inside it. This bubble has a name. It is called the heliosphere, and it is, in a real and almost territorial sense, the sun's own domain, the region of space that the sun's own breath has swept clear and claimed and continues to defend. But any bubble, however vast, has a surface. Somewhere, very far out, the solar wind has been blowing for so long and pushing for so far that it finally begins to run out of strength. Somewhere out there, the outward pressure of the sun's wind weakens until it exactly balances the inward pressure of the gas and the magnetic fields of interstellar space pressing back. And at that surface of balance, the wind can push no farther. It stops. It piles up. That surface, the outer skin of the sun's great bubble, is called the heliopause, and for a very long time, the heliopause was the best answer humanity had to the question of where the solar system ends. It is the wall of the sun's bubble, and it sits at roughly 120 astronomical units out from the Sunday. Now, for nearly all of human history, the heliopause was a purely theoretical thing, a deduction, a line on a calculation. We knew the sun had a wind, we could measure that much from near the Earth, and we knew that any wind must eventually stop somewhere, and so we knew, in principle, that the heliopause had to exist. But no one had ever been there. No instrument had ever touched it. It was real the way a place on a map can be real before anyone has actually visited it. And then two machines, two of the most remarkable objects human beings have ever built, changed that. In the year 1977, NASA launched two spacecraft, named Voyager One and Voyager 2. They were built, originally, for a tour of the outer planets, a grand survey of Jupiter and Saturn, and, for one of them, Uranus and Neptune, and they performed that tour magnificently. And then, their original mission complete, they did not stop. They had no reason to stop, and no way to stop, and so they simply kept going, outward, on trajectories that would carry them out of the solar system entirely, and never, ever bring them back. For decade after decade, they flew, growing colder, growing fainter in our radio dishes, their power supplies slowly dwindling. And then, on the 25th of August, in the year 2012, after 35 years of unbroken flight, Voyager 1, at a measured distance of 121.5 astronomical units from the Sun, crossed the heliopause. Voyager 2, travelling more slowly and in a different direction, crossed it 6 years later, in the year 2018, at a slightly different distance. For the first time in the existence of our species, human-built instruments stood at the outer wall of the sun's bubble, and they were sending word home. I want to slow down here, all the way down, and ride alongside Voyager One as it makes that crossing, because it is one of the only genuine frontier moments our species has ever actually recorded, an instrumented record of leaving, and it did not happen in anything like the way you might imagine. There is no wall. That is the first and most important thing to understand. There is no membrane, no shimmering barrier, no curtain, no line painted across the black. If you were riding on the hull of Voyager One, looking outward with human eyes, you would see nothing change at all. Nothing. The stars ahead would not flicker. There would be no boundary to watch approach and pass. What changes at the heliopause is entirely invisible to the eye, and it changes gradually, unfolding over weeks, and it shows up only in the readings of the instruments. For 35 years, the spacecraft has been bathed in the warm, familiar, steady drizzle of the solar wind, the sun's own particles streaming past it constantly, a sort of background rain from home. And now, slowly, over the course of weeks, that drizzle begins to thin. The count of solar wind particles drops, and drops further, and falls away toward nothing at all. And at the very same time, a different count begins to rise. Galactic cosmic rays, high-energy particles born far out in the wider galaxy, in supernova blast waves and violent distant places, particles that the sun's bubble had been holding back and shielding the inner solar system from, begin to arrive in greater and greater numbers. A colder, faster, sharper sleet, coming not from the direction of the sun, but from every direction at once. And the magnetic field, which for 35 years had pointed the way the sun's magnetic field points, slowly begins to swing, turning, like a compass needle drifting away from one north to find another. The wind from home dies away. The galaxy arrives. And the spacecraft, sailing on at exactly the same speed it has held the whole time, with absolutely nothing visible to mark the moment, passes quietly out of the bubble that the sun has been blowing since long before the Earth itself existed. The Voyagers, by crossing, taught us something we could not have learned any other way. They showed us that the heliosphere, that bubble of wind, holds back more than 70% of the galactic cosmic radiation that would otherwise come pouring into the inner solar system. The bubble is a shield. It is, quietly, without anyone on Earth ever feeling it or thinking about it, one of the reasons the inner solar system is as relatively gentle a place as it is. The wind that the sun blows is also the wind that protects. But here, now, comes the twist. And it is the twist that makes everything still ahead of us tonight necessary. The heliopause is not the edge of the solar system. It feels like it should be. It is dramatic. It is genuine. It is a real and measurable boundary. And 2 human spacecraft have actually crossed it and lived to send back the data. Everything in you wants it to be the edge. But it is only the edge of the sun's wind. It is the place where the sun's breath gives out. It is emphatically not the place where the sun's gravity gives out. And gravity, as we are about to see, reaches very, very much farther than wind ever could. We have come 120 astronomical units. We have crossed what the great majority of people, if you asked them, would name as the boundary of the solar system. And the truth is that we are still, even now, only just stepping off the sun's front porch. The structure that the sun's gravity genuinely holds, the true outer solar system, the real bulk of it, begins far, far beyond the heliopause, in a place no spacecraft has ever reached and no telescope has ever seen, and it is shaped like nothing at all on the map you were given. Part 5. The shell nobody has seen. To find the next layer, the one that lies beyond the heliopause, we have to do something unexpected. We have to go back in time. We have to travel to the middle of the 20th century, to the year 1950, and to a Dutch astronomer named Jan Oort. Oort never built a telescope to see the thing we are about to describe. He never could have, and neither has anyone since. What he did instead was something quieter, and in its own way far more remarkable than seeing. He looked at a catalogue. He looked at a list of comets and their orbits, and he did arithmetic, careful, patient arithmetic, and from that arithmetic alone he deduced the existence of the single largest structure in the entire solar system, a structure no human eye has ever directly seen, not before Oort, and not in all the decades since. Here is the puzzle that Oort was working on, sitting with his comet catalogue in 1950. We have already met one family of comets, the short-period comets, the Halley's Comet kind, the faithful ones that loop back every few decades from the Kuiper Belt. But there is a second family of comets, and I asked you earlier to hold on to the distinction, and now it pays off. The second family behaves in a completely, fundamentally different way. These are the long-period comets. A long-period comet does not return on any human timescale. It does not return on any timescale a civilization could track. It falls in toward the sun once, blazes around it in a single spectacular passage, and then departs on an orbit so vast, so enormously stretched, that it will not be back for thousands of years, or tens of thousands, or millions. Some of them, on the orbits we measure, are not strictly coming back at all. Oort noticed two things about these long-period comets, and each thing on its own was strange, and the two of them together were decisive, were enough to deduce a world. The first thing he noticed was the sheer size of their orbits. When he took a long-period comet and traced its path backward, outward, away from the sun, to its far point, the most distant place the comet ever reaches, that far point did not lie at 50 astronomical units. It did not lie at 100 or 1,000. It lay tens of thousands of astronomical units out from the Sunday. These comets were falling inward from a distance that simply dwarfed everything that he or anyone had ever been calling the solar system. They were arriving from somewhere unimaginably far out. The second thing Oort noticed was the direction the comets came from, and this was the clue that fixed the shape of the answer. The planets orbit the sun in a plane, a flat sheet, all of them travelling around in roughly the same level disk. The Kuiper Belt lies in roughly that same plane. The scattered disk is tilted, but it is still recognisably related to that plane. So if the long-period comets came from some kind of disk or belt, even a distant one, they would tend to arrive along the line of that disk. They would show a preference. They do not. The long-period comets come from everywhere. They fall inward from far above the plane of the planets and from far below it, from what we would loosely call galactic north and galactic south, from every direction in the sky with no preference whatsoever. They arrive evenly from all of it, and there is only one shape in geometry that can explain that. If comets fall inward equally from every direction in the sky, then the reservoir they are falling from must surround the sun equally in every direction. Not a ring, not a belt, not a disk, not even a vast tilted one, a shell, a sphere, a vast, hollow, spherical shell of icy bodies enclosing the sun and all the planets and the Kuiper Belt and the scattered disk and the entire heliosphere completely, wrapping around all of it on every side, the way the shell of an egg encloses the yolk within it. That spherical shell is what we now call the Oort Cloud, named in honour of the man who deduced it, who reasoned it into existence from a comet catalogue and a willingness to follow plain arithmetic all the way to a conclusion that must have seemed, when he first arrived at it, almost too large and too strange to be true. I want us to stop here, and stop properly, and feel what this discovery does to the map you were given, because this is the precise moment that the solar system turns inside out. Your entire life, you have pictured the solar system as a flat thing, a disk, planets running around on rings, all of them in one plane, the whole arrangement like a vinyl record or a dinner plate or a set of ripples on a pond, something you look down on from above and take in at a glance. That picture is not merely incomplete. Its very shape, the most basic fact about it, is wrong. The planets are flat. Yes, that part is true. The planets do orbit in a plane. But the planets are only the small, flat, inner detail of the thing. The solar system itself, the real and entire structure, the full extent of everything the sun gravitationally holds, is not a disk at all. It is a sphere. It is an immense hollow sphere, and the flat, familiar disk of the planets, the entire world of the map you were given, is a tiny ornament, a fleck, suspended at the exact center of that sphere. The shape of home, the most basic fact about the place you live, was never the shape you were taught it was, and the scale of this shell is the thing that genuinely strains the mind. The outer Oort cloud is estimated to begin somewhere around 20,000 astronomical units out from the sun, and to extend outward from there to somewhere between 100,000 and perhaps 200,000 astronomical units. Let me convert 100,000 astronomical units into a unit you have a real feel for. 100,000 astronomical units is about 1.5 light years. Light, which crossed a single astronomical unit in 8 minutes, needs 1.5 years to cross from the Sun to the outer Oort cloud. And the nearest star to the Sun, Proxima Centauri, lies just over 4 light years away. Put those together. The outer edge of the Oort cloud may reach 1/3 of the way to the nearest other star, possibly more. The Sun's territory does not end in some tidy little neighborhood just past Pluto. It reaches out a real, meaningful fraction of the entire distance to its stellar neighbors. The solar system is not a small thing, adrift in a huge emptiness. The solar system, properly measured, very nearly touches the next one. The Oort cloud is also, at last, where the long-awaited distinction between the comet families finally and fully pays off. Remember it. The short-period comets, the Halley's Comet kind, come from the Kuiper Belt, that flat inner ring. But the long-period comets, the ones on the orbits that take thousands or millions of years, the ones that arrive from every direction in the sky, those come from here, from the great surrounding shell, from the Oort cloud. So when a long-period comet blazes through the inner solar system, when one of the truly great comets hangs in a human sky and a whole generation looks up at it, you are looking at a visitor from the Oort cloud. You are looking at a single piece of the outermost solar system that has fallen, somehow, all the way in. That comet may have been drifting out there, untouched, in the dark and the deep cold, for the entire 4.5 billion year age of the solar system. And its passage across your sky, those few weeks of brightness, is very likely the one and only moment that piece of matter will ever spend in the light, in all of time, before and since. And here is the fact that I find, of everything tonight, the hardest to hold steady in my mind. We have never seen it. The Oort cloud is the largest structure in the solar system, by an enormous margin, and not one single human telescope has ever directly imaged even one of its members in place, out there where it lives. The individual bodies are too small. They are comet-sized, just a few kilometers across, mountains of ice adrift in the dark. They are unlit, far too far from the sun's warmth and light to shine, black objects against a black background. And they are tens of thousands of astronomical units away. Every single number I have just given you, the size of the shell, the population of it, the mass of it, every figure, is an inference. None of it is a photograph. It is all deduced, exactly as Oort first deduced it, from the comets that fall out of the cloud and into our view. It is knowledge of the kind you have when you stand inside an enormous darkened cathedral and know, with real certainty, that the space around you is vast, because you can hear the echo of it, the long, slow return of sound, even though you cannot see a single wall. The Oort cloud is, at one and the same time, the largest thing the Sun owns and the most hypothetical thing we discuss. It is the last thing that belongs to the Sunday, and in all our history we have only ever heard its echo. Part 6. Standing in the Cloud. I have been describing the Oort Cloud entirely from the outside, as a shell, as a structure, as a set of numbers, a span of astronomical units. But numbers, at this scale, stop carrying meaning. The mind goes numb to them. So, let us do something that the Voyagers cannot do, and that the telescopes cannot do, and that Oort himself could only ever do in his imagination. Let us actually go to the Oort Cloud. Let us travel out there and put our feet down on one of its bodies and simply stand and look around us and stay a while. Before we arrive, one last piece of geography, because the Oort Cloud is not a single uniform thing. It has an inner region and an outer region, and they have somewhat different characters. The inner region is sometimes called the Inner Oort Cloud, and sometimes called the Hills Cloud, after the astronomer Jack Hills, who predicted its existence in the year 1981, 3 decades after Oort. The Hills Cloud is the denser, somewhat flatter, somewhat more donut-shaped inner portion of the whole structure, and it runs from perhaps 2,000 astronomical units out to perhaps 20,000. Sedna, the strange detached object that first hinted to us that any of this existed at all, may well be a rare visible member of that inner Hills Cloud population, one of the very few whose orbit happens to dip close enough to the Sun for our telescopes to have caught it. And then, beyond the Hills Cloud, lies the outer Oort Cloud proper, the true spherical shell, sparser, vaster, colder, running outward to that staggering 100,000 astronomical unit frontier and beyond. So pick a body, choose a comet, a few kilometers across, a dark and ancient mountain of ice, somewhere out in the outer Oort Cloud, perhaps 50,000 astronomical units from the Sunday isn't, stand on it. Stay there with me. The first thing you notice, the thing you cannot help noticing, is the Sunday you go looking for it in the sky, and you find it, and it is not a disk. It is not a circle. It is not the warm, wide, golden face you have known your entire life. It casts no warmth on you. It casts no light you could read a page by. It does not show a disk you could resolve with your eye. It is a point, a single, brilliant, piercing point of light. It is, yes, the brightest point in your sky, brighter by far than any other star you can see, but it is only a point. And if you did not already know, with certainty, which point of light was the Sun, if you had simply been set down here knowing nothing, you might genuinely struggle to pick it out from the other bright stars scattered around you. Stop and let the full weight of that settle. The Sunday, the source of every joule of warmth, every photon of light, every scrap of energy, every living thing in the entire solar system. The object that the structure beneath your feet belongs to, the gravitational master of this whole vast region. From here, from inside its own outermost shell, the Sun is a brilliant point and no warmth. From here, the Sun is just a star. The second thing you notice is that there is no down. On a planet, the word down means something solid and reliable. It points toward the core, toward the ground, toward the center of a world, and your whole body is built around the certainty of it. Here, standing on a comet only a few kilometers wide, the gravity is so unimaginably faint that down barely exists at all. You do not really stand on this body, you drift against it. A careless push of your legs could send you slowly, irrevocably, off its surface and into space. There is no horizon worth the name. There is no landscape, no terrain, no scenery. There is a small dark curve of 4.5 billion-year-old ice beneath you, and then there is the entire universe, in every direction at once, and nothing your body's senses can do will tell you which way is anything at all. And the third thing you notice, the thing that takes the longest to truly absorb, the thing that changes you a little, is how alone this place is. You might imagine the Oort Cloud, knowing that it holds hundreds of billions, perhaps trillions, of comets, as a crowded place, a swarm, a dense field of icy bodies you could see drifting all around you, near neighbours in every direction. It is the precise opposite. The Oort Cloud holds an almost uncountable number of bodies, that is true, but it holds them spread across a volume so unthinkably, so incomprehensibly vast, that the bodies are, on average, tens of millions of kilometres apart from one another. Tens of millions of kilometres. Your nearest neighbouring comet, the single closest other object in this entire enormous shell, is farther away from you right now than the Sun is from Saturn. You could not see it. There is no telescope you could hold in your hands that would show it to you. You could not signal it. If it were the only other object in your sky, you would still never know that it was there. The Oort Cloud is not a swarm and not a cloud in any sense that the word brings to mind. It is the most profound and complete solitude in the entire solar system. It is a place where every single body drifts utterly alone, in silence, in darkness, in a cold close to the lowest cold that the universe permits, and where each one has drifted exactly that way, alone, for 4.5 billion years, and will go on drifting exactly that way for billions of years still to come. There is one more thing to feel, standing here, before we move on, and it is the quietest of all of them. It is the silence. Not silence as the absence of a particular sound, but silence as something close to a total state. There is no air out here to carry sound at all, so there is nothing to hear in the ordinary sense, and there never has been and never will be. But it goes deeper than that. There is no event out here to make a sound even if there were air. Nothing happens on a timescale you could perceive. The comet beneath you does not shift. The sun does not visibly move. The stars hold their positions. You could stand on this body for 100 years, and nothing in your sky would change in any way a human eye could register. The Oort Cloud is not just dark and cold and empty. It is still. It is the stillest place there is. A place where 4.5 billion years can pass and leave no visible mark, and where the few great events that do happen, a comet nudged loose, a star passing far off, are spread so thin across the deep time that any given moment, the moment you are standing in, is almost certainly a moment in which nothing at all is happening anywhere you could see. And yet this stillness is not death and not nothing. It is the sun's outermost shell, holding its shape, holding its comets, doing exactly what it has done since the solar system was young. Stand here long enough, in that solitude, and a strange and specific doubt begins to creep into you. You are, technically, by every definition astronomers use, still inside the solar system. This comet beneath your feet is bound to the sun, held in orbit by the sun's gravity, a genuine possession of the sun's, a true member of the sun's family. That is a fact. But nothing at all, that your senses are reporting to you agrees with that fact. The sun is a point among other points. The other stars of the galaxy are scattered all around you, in their thousands, and several of them are nearly as bright in your sky as the sun is, and one or two may even be brighter. There is no warmth. There is no disk. There is no glow, no light, no sense whatsoever of belonging to anything, of being held, of being home. If someone set you down here without telling you where you were, you would not say you were in the solar system. You would never say that. You would say you were lost, somewhere out among the stars of the galaxy, and here is the thing I most want you to take from this place. That doubt, that exact and specific doubt, is not a mistake your senses are making. It is the most honest thing your senses could possibly tell you. Because we are now approaching the place where that doubt stops being a feeling and becomes the literal, measurable truth. We are approaching the place where the sun, quietly, with no wall and no warning and no event of any kind simply stops being able to hold on. Part 7. Where the Sun loses its grip. We have crossed the heliopause, the edge of the Sun's wind, and it is far behind us now, an inner detail. We have reached and stood within the Oort Cloud, the edge of the Sun's family of comets. There is exactly one boundary left to find, and it is the deepest of them all, and it is the one with the truest and most defensible claim to being the real edge of the solar system. It is the edge of the Sun's gravity, and to understand it properly, we have to hold on to a fact that is genuinely easy to forget when you spend your whole life living close to a star. The Sun is not the only source of gravity that matters out here. The entire rest of the Milky Way galaxy is pulling too, all the time, on everything. Gravity, famously, never switches off. It has infinite range. The Sun's gravitational pull reaches outward forever, growing weaker and weaker with distance, fading, but never quite reaching zero, never fully stopping. So, in the strictest technical sense, the Sun pulls on everything in the universe, on every distant galaxy. But there is a crucial difference between pulling on something and holding onto something. To pull on an object is one thing. To hold onto it, to keep it bound, to keep it in a stable orbit, to keep it as a member of your family, the Sun's pull on that object has to be stronger than the combined competing pulls of everything else in the universe tugging the other way. And the everything else, out here at the Oort Cloud, is the entire Milky Way galaxy, 400 billion other stars, vast cold clouds of gas, the galaxy's own enormous reservoir of dark matter. All of it has gravity. All of it is pulling. There is, therefore, a distance, a specific range, at which the Sun's grip and the galaxy's grip come into balance with one another. Inside that distance, the Sun wins the contest, and an object stays bound to it, stays in orbit, remains a true member of the solar system. Outside that distance, the galaxy wins, and an object is no longer reliably held by the Sun at all. Astronomers have a name for the region within which a body's gravity dominates over outside influences. They call it the body's Hill sphere. And the Sun's Hill sphere, the true gravitational extent of the solar system, the region within which the Sun genuinely rules, reaches out to somewhere around 1 to 2 light years. Roughly 100,000 to 125,000 astronomical units. And notice immediately what that means. The outer edge of the Oort Cloud and the edge of the Sun's gravitational dominion are, more or less, the very same place. This is not a coincidence. The Oort Cloud does not simply happen to be the outermost structure. The Oort Cloud is the outermost structure that the Sun is gravitationally capable of having at all. You cannot have a stable shell of comets beyond the reach of your own grip. The Oort Cloud extends precisely as far as the Sun can hold it, and not one astronomical unit farther. But now comes the part that genuinely, fundamentally changes the shape of the answer we have been chasing all night. You might reasonably expect this gravitational edge, this Hill sphere boundary, to be a clean and definite thing, a specific distance, a sphere with a real surface, a place where you could stand and say with confidence, here, exactly here, on this side, the solar system, on that side, the galaxy. It is not that. It is not a surface at all. It is a fade. Here is why. The galaxy does not pull on an Oort Cloud comet from a single direction in a simple, uniform way. The galaxy's pull is spread out across the whole sky, and, crucially, it is slightly uneven. A comet far out in the Oort Cloud is being pulled, gently, toward the distant centre of the Milky Way, and the side of that comet's wide orbit which faces the galactic centre feels a very slightly stronger pull than the side of the orbit which faces away from it. That difference, that gentle unevenness in the galaxy's pull stretched across the enormous span of a single comet's orbit has a name. It is called the galactic tide. And it is, in its underlying physics, the same kind of effect as the ocean tides that the moon raises on the Earth. The moon pulls slightly harder on the near side of the Earth than the far side, and the oceans respond, and we get tides. Here, it is the entire mass of the galaxy, gently raising a tide on the outermost shell of the solar system. And the galactic tide does not switch on at a sharp and definite distance. It grows. Smoothly, continuously, the farther out you go, the farther out a comet sits, the more the galactic tide matters to it, and the less securely the sun holds it. So there is no fence at the edge of the solar system. There is no wall, no surface, no line. There is, instead, a vast region, light years across, a long, slow gradient, within which the sun's authority gradually and continuously weakens, while the galaxy's authority gradually and continuously strengthens, and somewhere in the broad middle of that gradient, the balance tips from one to the other. But you could never point to the exact place where it tips, because there is no exact place. The transition is smooth. The edge of the solar system is not a line, and never was. It is a handover. It is a twilight zone, light years in width, in which belonging to the sun, slowly, smoothly, with no event and no moment and no crossing, simply stops being true. Sit with that, because it is one of the strangest and most overlooked facts about the place that you live. You almost certainly believe, somewhere in the back of your mind, in a quiet, unexamined way, that the solar system has an edge the way a country has a border, a definite line, a place you cross, where one thing ends and the next begins, and you could in principle stand with one foot on each side. It does not have that. It never has. Ask an astronomer to point to the edge of the solar system, to give you the distance, the single number, and they cannot do it, and it is not for any lack of knowledge. They know the Hill sphere, they know the galactic tide, they know all of it in fine detail. They cannot do it, because the thing you are asking them to point to is not the kind of thing that has a single location. Home does not have a wall. Home has a frontier that fades gradually over a distance so vast that light itself needs a year or more to cross it into something that is no longer home. And once you genuinely know that, once you have taken it in, the next discovery of the night becomes almost inevitable. Because if the edge of the solar system is a fade and not a wall, then the edge of the solar system is not a barrier either. And things, as we are about to see, can come through it. Part 8. The galaxy reaches in. For almost all of this journey, it has been natural, almost unavoidable, to picture the solar system as a container, a bubble, a shell, an enclosed space with the sun burning at the middle of it and a boundary drawn around the outside, and then, beyond the boundary, the galaxy, the separate outside thing. It is a comforting picture. It puts a wall between us and the vastness. It is also, as we are now going to see clearly, simply wrong, and the galactic tide is the thing that makes it wrong. We met the galactic tide a moment ago, in its first role, as the thing that makes the edge of the solar system a fade rather than a line. But the tide does much more than blur a boundary. The tide is active. It is, slowly and continuously, all the time, doing something to the Oort Cloud. And what it is doing turns out to be the answer to a question we have been quietly carrying with us since very early in tonight's journey. The question is this: where do the long-period comets actually come from? Not which reservoir. We know the reservoir. It is the Oort Cloud. The real question is, what sends them? What starts them falling? A comet sitting peacefully out in the outer Oort Cloud, 50,000 astronomical units from the Sun, drifting along on its slow, stable, near-circular orbit, has no reason on its own to suddenly abandon that orbit and fall all the way inward toward the Sun and blaze across some inner sky. Something has to disturb it. Something has to reach out, take hold of that specific comet, and change its orbit so that instead of circling far out in the safe dark, it now plunges sunward. That something, the main something, is the galactic tide, the very same gentle, uneven, galaxy-wide pull that blurs the solar system's outer edge also, over millions of years of patient work, slowly reshapes the orbits of the comets in the Oort Cloud. It stretches some of them. It tilts others. It works on them, slowly, the way water works on stone. And every so often, the tide stretches a particular comet's orbit just enough that the comet's near point, the closest the comet ever comes to the Sun, drops. It drops from far out in the Oort Cloud, all the way down through the Hills cloud, down into the realm of the planets. And once that has happened, once the near point has been pulled down low enough, the comet falls. On its next long inward swing, it comes plunging in across the whole vast structure we have spent tonight crossing, past the outer Oort Cloud, past the Hills cloud, past the heliopause, past the Kuiper Belt, in toward the warmth and the light. And it grows a coma, a glowing head, and it grows a long, bright tail, and for one brief passage, a few weeks, it becomes a comet in the full human sense of the word, a bright and beautiful thing hanging in somebody's night sky. And the hand that set it falling, the hand that started the whole long plunge, was the gravity of the galaxy itself. Think very carefully about what that actually means, because it is a genuine reversal of the picture in your head. It means that the great comets that have crossed human skies all through history, the long-period ones, the ones that whole civilizations have looked up at and feared and recorded and built omens around, were not sent inward by anything inside the solar system. They were not dispatched by the Sun or by any planet. They were sent inward by the Milky Way galaxy. The galaxy reached across the fading outer edge of the Sun's territory, took hold of a comet that had been drifting untouched and alone for 4.5 billion years, and flicked it sunward toward us. The boundary of the solar system is not a barrier that the galaxy politely remains outside of. The boundary is a thing the galaxy reaches straight through. The galaxy already has its hand inside the solar system. It always has. And the proof of it has been streaking across our skies, occasionally, gloriously, terrifyingly, for as long as there have been skies for it to streak across, and for as long as there have been eyes turned up to watch. There is something worth pausing on in the timescales here, because the timescales are part of why this is so easy to miss. A comet drifting in the outer Oort Cloud takes millions of years to complete a single orbit. The galactic tide does its slow stretching work across spans of tens and hundreds of millions of years. A human life, against that, is not even an instant. It is less than an instant. And so the galaxy reaching its hand into the solar system is not something you could ever watch happen. It is not an event. It is a process so slow that across the entire span of human civilization, across every comet anyone has ever recorded, the Oort Cloud has barely stirred at all. What we see, when we see a great long-period comet, is a single grain of sand falling, and we mistake the stillness around it for permanence. The cloud is moving. It is simply moving on the clock of the galaxy, and the galaxy's clock and your clock have almost nothing to do with one another. When you understand that, the Oort Cloud stops being a static shell in a diagram and becomes something closer to a vast, slow weather system, one that has its own seasons measured in hundreds of millions of years, and we happen to be alive during one quiet moment of one of them. And consider what this means for the comets themselves, the individual bodies. A comet that the galactic tide finally sends falling sunward has, in almost every case, been waiting in the dark for the entire age of the solar system to do it. 4.5 billion years of perfect, frozen, undisturbed stillness, and then a slow gravitational nudge, and then the long fall. And the fall itself, from the outer Oort Cloud all the way down to the Sun, is not quick either. It can take 1,000,000 years or more for a comet, once it has been set loose, to complete that single inward plunge. So when one of these great comets finally appears in a human sky, you are seeing the final few weeks of a journey that began before there were human beings, before there were primates, on an object that was nudged loose by the gravity of the galaxy itself, and has been falling toward this one bright moment ever since. The brevity of the comet in your sky and the depth of the time behind it are almost impossible to hold together in one thought. But they are both true, and the truth of them is the truth of the whole outer solar system. Out here, everything that looks sudden is the visible tip of something unimaginably slow. This reframes the Oort Cloud itself, and we should let it. We have been describing the Oort Cloud as a shell, a structure, and those words carry a sense of stillness, of something finished and settled and inert. The Oort Cloud is none of those things. It is not static. It is a slowly churning reservoir. Over millions and over billions of years, the galactic tide stirs it continuously, the way a slow, deep current stirs a vast, still pool, lifting some comets onto new and wider paths, dropping others inward toward the fire, occasionally, as we will see in just a moment, having that gentle stirring sharpened by something far more sudden and dramatic than a tide. The Oort Cloud is alive in exactly the way that geology is alive. It moves and changes and works on timescales far, far longer than a single human life, but it is unmistakably, measurably in motion. And it is in motion for one reason above all. It is in motion because it is not sealed off from the galaxy. It is continuous with the galaxy. The comfortable container picture is gone now, and we should let it go. The solar system is not a closed bottle drifting through an empty sea. It is an open, porous, weather-beaten region of space, with a fading edge that the galaxy reaches through, and reaches through in both directions. We have just watched the galaxy reach in and pull a comet out of the cloud and send it falling toward the Sunday. Now we are going to watch something travel the other way. Now we are going to watch the galaxy send something in. Part 9. Visitors from other suns. In October of the year 2017, a telescope on a mountaintop in Hawaii caught a faint moving dot against the field of stars. It was the kind of thing that telescope catches routinely, a smudge of light shifting slightly from one night to the next. But within a few days, the astronomers studying it realized they were looking at something no human being had ever confirmed seeing before in all of history. They named it Oumuamua. It is a Hawaiian word, and it means, roughly, a scout or a messenger from the distant past, one reaching out to make contact. The name turned out to be exactly, almost eerily, right, because Oumuamua was not from here. It was not from the solar system at all. How can you tell, with certainty, that an object is not from here? You do not tell it by what the object is made of, at least not at first. You tell it by how the object moves. Every comet, every asteroid, every planet, every moon, everything that is gravitationally bound to the sun travels on a closed orbit, a loop, an ellipse, a path that goes out and comes around and returns, again and again, forever, because it is held. That is what being bound means. Oumuamua's path was not a loop, it was open. It was a hyperbola, which is the shape of a path that comes in toward the sun exactly once, bends sharply around it, and then leaves, climbing away forever, never slowing enough to return. Its speed, too, was wrong for a member of the solar system. It was moving too fast, far too fast, to be bound to the sun, too fast for the sun's gravity to ever pull it back. And when astronomers carefully traced its incoming path backward, before it reached the sun, they found that it had not come from the Oort Cloud, or the Kuiper Belt, or the scattered disk, or anywhere at all within the sun's territory. It had come from interstellar space. From outside, it was a piece of some other star system entirely, a fragment drifting through the wider galaxy, and it had simply, briefly, by pure chance, fallen through ours. Let me place you alongside it, the way we have stood in so many places tonight. You are riding with a fragment of rock and ice, perhaps a few 100 meters long, dark and reddish in color, and oddly, strikingly elongated, far longer than it is wide, and it is tumbling. It is turning end over end, slowly, the way a thrown bottle turns in the air. It has been tumbling like this for an immense, almost unmeasurable span of time. For hundreds of millions of years, very possibly longer, this single fragment has been crossing the dark between the stars, alone, untouched by anything, in a cold and a silence that has had no sun in it at all, no warmth, no light, only the faint distant scatter of the galaxy's stars wheeling slowly past. It was made somewhere else, around some other star, in some other system's version of the structures we have explored tonight. And long, long ago something, a passing star, or a giant planet, or the slow work of a tide, flung it out of its home system entirely, cast it loose, and ever since it has simply been falling through the galaxy, with no destination and no name and no home. And now, for the first time in all those hundreds of millions of years, and almost certainly for the only time, a star is close. The sun grows, ahead of the fragment, from a point of light into a small disk, and then a larger one. For a few brief months, this nameless tumbling fragment is washed in warmth and bathed in light, light it has not felt since the day its own home system cast it out into the dark. Its path bends under the sun's pull. It curves around the sun and the inner solar system, the planets, the warmth, all of it sweeps past in a matter of a few weeks. And then the sun begins to shrink again behind it, dwindling from a disk back down to a point, and the old cold closes back in around the fragment, and it goes back to the dark, carrying nothing of us away with it, leaving nothing of itself behind, except that for a few weeks, on a small blue world it passed, beings looked up and tracked it and learnt its name. Oumuamua had one more strange thing about it, one final puzzle. As it left the inner solar system, as it climbed away, it sped up, very slightly, but measurably, by a little more than the sun's gravity acting alone could account for. Now, comets do this. It is normal for a comet. As a comet warms, it vents gas from its surface, and the venting gas acts like a tiny thruster, giving the comet a small, gentle push. But Oumuamua showed no visible tail. It showed no obvious coma, no clear sign of venting anything at all. And so, the small, extra push it received remains, to this day, not fully explained. The leading scientific ideas for it are natural ones. Perhaps it vented ices we simply could not see from Earth, gases that do not glow brightly. Perhaps it had an unusually thin, fluffy, low-density structure, so light that the faint pressure of sunlight itself was enough to nudge it. Some people speculated about stranger explanations, and we are going to deal with that fairly and directly in just a moment. But the honest scientific position, the one the evidence actually supports, is this. Oumuamua revealed how very little we know about the small bodies that drift between the stars, and it revealed that because it was the first one we had ever caught, you cannot generalize from a single example. We had one. It was not the last. 2 years later, in the year 2019, an amateur astronomer named Gennady Borisov, observing the sky with a telescope that he had built himself by hand, found a second one. This second object, named Borisov after its discoverer, was also unmistakably on an open, unbound, hyperbolic, interstellar path. It too had come from outside and was leaving forever. But Borisov was not ambiguous and bare the way Oumuamua had been. Borisov was, beyond any doubt, a comet. It had a coma, a glowing head of gas surrounding it. It had a tail. It behaved exactly as a comet behaves. It was a comet from another star, carrying within it the frozen chemistry of a planetary system that was not the sun's, the ices, and the compounds of another system's cold outer reaches, and we got to watch it steam and glow in our own sky as it passed. Here is what these two visitors, Oumuamua and Borisov, mean for tonight's journey, and it is the heart of why they matter. Every star that has an Oort cloud, and we have every reason now to believe that Oort clouds are common, that they are an ordinary feature of star systems, leaks, comets. The galactic tide and the passing of stars stir other stars' Oort clouds in exactly the same way they stir our own. And some of those stirred comets are not merely flung onto new orbits within their home system. Some are flung out of it entirely, ejected, cast loose into interstellar space to drift forever. Oumuamua and Borisov are exactly that. They are pieces of other stars' Oort clouds. They are samples, delivered by pure chance right to our doorstep, of the very same kind of structure we have spent this entire night exploring, only built around a different sun. And they pass straight through the region we have been describing, straight through the fading porous edge of the solar system. This is the proof, the physical, observed, named and tracked proof of what we deduced in the last part. The solar system has never been sealed. The galaxy has always been able to send pieces of itself inside, and we are, right now, just entering an era in which we will see this, not rarely, but constantly. A new observatory, the Vera Rubin Observatory, with a camera and a survey strategy built precisely for catching faint moving things, is expected to find these interstellar visitors not once a decade, the way it has been, but possibly many times every single year. The rarest of all curiosities is about to become a steady, ordinary stream of messengers arriving from beyond the Oort cloud. Part 10. The Neighbours Pass Close. We have watched the galaxy reach into the solar system with its tide, taking hold of comets and sending them falling sunward. We have watched the galaxy send whole objects through the solar system from outside, the interstellar visitors falling through on their open paths. There is one more way that the wider galaxy touches the Oort cloud, and it is the most direct of all of them. Sometimes the neighbours themselves come to visit. Sometimes a star comes close. We tend, all of us, to imagine the stars as fixed. They hold their constellations night after night, year after year, lifetime after lifetime. The same patterns your grandparents looked up at are the patterns you look up at now, and so it is entirely natural to think of the stars as nailed in place, as a permanent backdrop. They are not. Nothing in the galaxy is fixed. Every star in the Milky Way is moving, the Sun very much included, all of us orbiting the distant common centre of the galaxy, and all of us also drifting, slowly, relative to one another, each star on its own slightly different path. The constellations hold their familiar shapes only because the stars are so enormously far away that their motion across our sky is far too slow for a single human life, or even many human lives stacked together, to notice. But over long enough spans of time, the stars do wander. They drift. They approach one another, and they recede, and every so often one of them passes close enough to the sun to brush against the outer Oort cloud. This is not speculation. It is not a maybe. It has genuinely happened, and recently, in cosmic terms. There is a small, dim star, a red dwarf, travelling with a companion as part of a binary pair that astronomers call Schultz's star. Today, right now, Schultz's star is about 20 light-years away from us. Unremarkable. Just one more faint point. But trace its motion carefully backward through time, and you find that roughly 70,000 years ago, Schultz's star passed within about 8/10 of a single light-year of the Sunday. 8/10 of a light-year. Hold that against the numbers we built earlier tonight. The outer Oort cloud may reach out to 1.5 light-years or more. 8/10 of a light-year is well inside it. A star, another sun, passed directly through the outer shell of our own solar system. And it happened while human beings were already alive and walking on the Earth. Our ancestors, the people living 70,000 years ago, were there for it. They could have seen it, a faint red star, low and dim, that over some long period brightened slightly and then slowly faded again. A slow, quiet flare in the prehistoric sky that no one wrote down because there was no writing, and that no one could possibly have understood, but that some of them, surely, on some clear, cold night, looked up and noticed. And it will happen again. In the other direction, in the future, there is a star called Gliese 710. It is a small orange star, and today it sits at a comfortable, safe distance from us. But it is moving, and it is moving roughly our way, and in about 1.3 million years from now, Gliese 710 is predicted to pass within roughly 1/6 of a light year of the Sunday. That is closer, considerably closer, than Schultz's star came. 1/6 of a light year is not the outer fringe of the Oort Cloud. That is deep inside it. It places Gliese 710 somewhere around 10 to 13,000 astronomical units from the Sun at its closest approach, well within the shell, possibly passing right through the denser inner Hills cloud. When a star passes that close, its gravity does not gently blur and stir the Oort Cloud the way the slow, steady galactic tide does. It yanks it. A close stellar passage can take hold of a whole population of Oort Cloud comets, thousands upon thousands of them, all at once, and fling them onto new orbits in a single gravitational event. And some fraction of those flung comets will be sent plunging inward toward the Sunday. The result, after a close stellar passage, is not a single comet. It is a comet shower, a long, slow, sustained rise in the number of long-period comets falling into the inner solar system, a raised rate that can last for 1,000,000 years or more after the passing star itself has come and gone and vanished back into the galaxy. So the Oort Cloud is stirred in two ways, on two rhythms. It is stirred gently and constantly every day by the galactic tide, and it is stirred sharply and occasionally on the rare close passes by the gravity of a passing star. It is a reservoir that the entire galaxy, in several different ways, has its hands on at all times. This is also the right moment, the honest moment, to deal directly with the hidden bodies. Because the outer dark we have been exploring all night has always attracted stories. People have always wanted to put something out there, in the part of the map nobody draws. And some of those stories are real, careful science, and some of them are not science at all, and being able to tell the two apart is itself one of the most valuable things this journey can give you. So let us take the real science first. There is a genuine, serious, peer-reviewed scientific hypothesis, and it is called Planet 9. It proposes that the curious orbits of a handful of the most distant objects we have found out past Neptune, the strange way that several of them seem to have their orbits pointed and tilted in a similar direction, as if something were herding them, are best explained by the gravity of a real, undiscovered planet. Something with perhaps 5 to 10 times the mass of the Earth, orbiting far out, hundreds of astronomical units from the Sun, out in the general direction of the inner Oort Cloud. Now, Planet 9 may not exist. The orbital clustering that the whole hypothesis rests on is genuinely debated among astronomers, and it may yet turn out to be a statistical illusion, an artifact of the particular patches of sky we happen to search hardest. But it is a real hypothesis. It was put forward by serious, respected astronomers doing careful work, and the new generation of sky surveys may well settle the question, one way or the other, within just a few years. And if Planet 9 does turn out to be real, it would be the true 9th planet of the solar system, and its home, its orbit, would lie out in the very region we have been travelling through tonight. And then there are the stories that are not science. There is a claim a persistent one that resurfaces every few years, like a tide of its own, of a hidden planet, often called Nibiru or Planet X, said to be on a collision course with the Earth, due to arrive imminently and bring about the end of the world. And it is worth saying this clearly, and saying it without any unkindness, because people do genuinely worry about it. There is no such object. There is nothing there. A planet on a path that would bring it crashing into the inner solar system in the near future would not and could not be hidden. It would be one of the brightest objects in the entire night sky. Anyone could see it. And its gravity, on its way in, would already have visibly, measurably disturbed the orbits of the planets we can see, of Mars, of Jupiter, and we would have detected that disturbance long ago. It is simply not there. And there was an older idea, a real scientific proposal from the 1980s called Nemesis. Nemesis was a hypothesized dim companion star to the Sun, a faint, distant stellar partner whose regular passages through the Oort Cloud would, the idea went, trigger periodic comet showers and drive mass extinctions on Earth on a cycle of roughly 26 million years. Now, Nemesis was real science in its day. It was a careful proposal, and crucially, it made a real, testable prediction. It predicted that a faint companion star should be out there, findable, and that is exactly why we can now say, with confidence, that it is wrong. Infrared sky surveys, instruments capable of detecting a cool, dim star anywhere in the relevant region of space, have done the search. There is no Nemesis. The Sun has no hidden stellar partner. And I want you to notice the pattern in all of this, because the pattern is the real and lasting lesson. The invented hidden bodies, the doomsday planet, the Death Star, the dramatic ones, the frightening ones, are dramatic, and they are also, every one of them, absent. They are not there. The real outer solar system is stranger than any of them, and emptier, and the genuine mysteries it actually does still hold, an unseen possible planet we cannot yet find, an entire enormous shell we have never once imaged, an edge that turns out not to be a place at all, are quieter and less cinematic, and in the end far more unsettling than any story anyone ever invented to fill the dark. Part 11. What is actually out there? We have come a very long way. Let us take a breath and count the ground covered. We have passed Neptune, the last of the planets. We have crossed the Kuiper Belt and stood at its strange, sharp cliff. We have moved through the scattered disk and slowed down for Sedna and its impossible detached orbit. We have crossed the heliopause, the edge of the sun's wind, the boundary two human spacecraft have actually touched. We have travelled through the inner hills cloud and out into the great spherical outer Oort Cloud, and we have stood on one of its lonely comets. We have reached the fading gravitational edge, the long twilight where the sun's grip gives way to the galaxies. We have, at last, in every sense the word allows, crossed the last thing that belongs to the Sunday. So now, finally, standing out here past all of it, we can answer the question in the title in the plainest and most direct way possible. We are beyond the Oort Cloud. What is here? What hides in this place? The first thing to say is what is not here, because what is not here is exactly the thing the map you were given promised you: emptiness. The poster told you, without words but unmistakably, that past the last planet there was nothing. Clean black empty space, a total void, running uninterrupted all the way to the next star. That is wrong. It is one of the deepest things the map got wrong. Interstellar space, the space between the stars, is not empty. It is filled. Thinly, yes. It is filled far more thinly than the very best, hardest vacuum that any laboratory anywhere on Earth can produce. But it is filled. It is filled with gas, mostly hydrogen, the simplest and most common element there is, and it is filled with fine grains of dust, and all of it is spread out across the light years. This material, this thin, pervasive stuff, has a name. It is called the interstellar medium, and it is a real substance and a real environment with a measurable temperature and a measurable density and a structure of its own. Beyond the Oort Cloud is not nothing. Beyond the Oort Cloud is the galaxy's own thin, vast, drifting body, the medium that fills the galaxy between its stars, and the entire solar system is sitting inside it. In fact, the solar system is not merely sitting inside it, passively. The solar system is moving through it. Right now, this very moment, carrying you and everyone you have ever known, the entire solar system is sailing through a particular wisp of that interstellar medium. It is a small, warm, slightly denser than average cloud of gas, about 30 light-years across, and astronomers call it the local interstellar cloud. The Sun drifted into this cloud sometime within roughly the last several tens of thousands of years, a cosmic eye blink ago, and it is expected to drift back out the far side of it within roughly the next 1900 years. We are passing through it the way a ship passes through a single patch of weather on a long ocean voyage. And the heliosphere, that bubble of solar wind whose outer wall we crossed so very long ago, near the start of tonight, is the bow of that ship. Its shape is not a perfect sphere. It is compressed on the side facing into the solar system's motion and drawn out into a long tail on the side behind. And that shape is carved, in part, by the interstellar wind that the solar system is sailing into as it moves. Think about what that means. The bubble that shields the inner planets, that holds back the cosmic rays, is itself shaped, partly, by the weather of the medium outside it. The inside is shaped by the outside. The two were never truly separate. It is worth letting the strangeness of that settle, because it overturns one more piece of the map you were given. The map showed the Sun fixed at the center, motionless, with everything orbiting around it, and that picture quietly suggested that the solar system was a settled, parked thing, and that the space around it was a fixed and permanent setting. Neither is true. The solar system is moving, all of it together, the Sun and the planets and the Oort Cloud, sweeping through the galaxy at a real and considerable speed, and as it moves it passes from one patch of interstellar weather to the next. Tens of thousands of years ago, the solar system was in a different region of the medium than it is now. Tens of thousands of years from now, it will be in another. The local interstellar cloud is not the solar system's home address. It is just the stretch of space the solar system happens to be passing through during the brief window that includes all of human history. The setting itself is moving past us, slowly, the way the landscape moves past the window of a train. Nothing out here is fixed. The stars drift, the clouds drift, the bubbles shift and merge, and the solar system sails on through all of it, and the only reason any of it looks permanent is that we measure it against a human life, and a human life is far too short to catch the motion, and we can zoom out one level further still. The local interstellar cloud, our current patch of weather, itself sits inside something far larger. It sits inside what astronomers call the local bubble. The local bubble is an immense cavity in the interstellar medium, roughly 1,000 light-years across, a vast region that was swept unusually clean and heated to an unusually high temperature by the violent deaths of ancient stars. Supernovae, the explosions of massive stars, detonated across this region millions of years ago, and their blast waves blew a great hollow chamber into the galaxy's gas. The solar system, with its sun and its planets and its unseen Oort Cloud, is one small, slowly moving point, drifting somewhere inside that 1,000 light-year hollow. We are inside a cloud that is inside a bubble that is inside the galaxy. The structure goes on, in every direction, at every scale. Let me put you out there, one final time tonight, drifting just past the heliosphere, out in the interstellar medium itself, so that you can feel, directly, what beyond actually is. It is not dramatic. That is the first surprise, and in a way it is the deepest one. There is no roaring void out here. There is no abyss, no terror, no sense of falling. There is, instead, a thin and faint and almost imperceptible warmth of gas all around you, the local interstellar cloud, far too tenuous for anybody to actually feel, but really, genuinely, measurably present, at a temperature of several thousand degrees and a density so staggeringly low that a whole cubic centimetre of this space, a volume the size of a sugar cube, holds only a fraction of a single atom. Behind you, sunward, you can see the heliosphere, the sun's bubble, an enormous, soft, faintly luminous shape, and you understand now, in a way you did not at the start of the night, that it is not the solar system. It is just the solar system's sail, its bow wave, the shield it pushes ahead of itself through the galactic weather. And the sun itself, when you turn and search for it and find it, is a brilliant point and no warmth. Exactly, precisely, as it was from the surface of that lonely Oort Cloud comet, the same piercing point of light, except that now there is no doubt left to resolve, no uncertainty to sit with. From here, out past the last comet, the sun is not the centre of your sky and not the master of your world. It is one star in a field of stars, a bright one, a near one, but a neighbour now, not a home. You have genuinely, completely left. And the strangest part of standing here, in this thin, warm dark, is the realization that the galaxy on this side of the edge and the solar system on the other side of it were never, ever two separate things. The interstellar medium flows around and even through the heliosphere. Interstellar objects fall inward across the boundary. The galactic tide reaches in. The sun's own comets leak steadily out. The edge of the solar system is not a wall standing between two worlds. It is a shoreline. It is a place where the sun's small warm water and the galaxy's vast cold water meet and mingle and mix, and tonight we have simply waded out from the shallows, past the last comet, and into the open sea. Part 12. The edge that cannot be pointed to. Now, at the very end of the journey, I want you to go back and find the map you were given, the poster on the classroom wall, the glossy page in the school book, the tidy, simple, complete-looking picture from childhood, the sun, the neat concentric rings, the planets in their proper order, the last small cold dot, and the black emptiness drawn carefully past it. You can see that map differently now. You cannot unsee what we have seen tonight. For almost your entire life, that blank black region past the last drawn planet read as one thing. It read as the edge of the map, the place where the solar system stopped and where nothing began. We can now, finally, name what that blank black region actually was. It was not the edge of the solar system, it was the solar system. It was almost all of it. The Kuiper Belt and its unexplained sharp cliff, the scattered disk, Sedna, riding its 11,000-year orbit out into the dark, the heliosphere and its invisible crossing, the inner hills cloud, the great spherical outer Oort Cloud, reaching a third of the way or more to the very next star, the slow churn of the galactic tide, the fading gravitational frontier, the interstellar visitors falling through, all of it, the overwhelming majority of the entire structure that the sun gravitationally holds, was sitting right there, the whole time, in the part of the page that nobody ever draws. The map you were given did not get the edge wrong. It is subtler and stranger than that. It left off the body. It showed you the lamp, and a few small things gathered close around the light, and it cropped away the entire rest of the room and handed you the crop. And what did we actually find when we travelled out through that cropped-away room? We found that the simple question we started the night with, the question of where the solar system ends, does not have the simple kind of answer that you expected it to have. We found not one edge, but at least 4, and every one of the 4 has a real and defensible claim. There is the Kuiper Cliff, the sharp, mysterious drop in the icy ring at around 48 astronomical units. There is the heliopause at around 120, the edge of the sun's wind, the boundary that 2 spacecraft have genuinely crossed and measured. There is the Oort Cloud, the edge of the sun's vast family of comets, reaching out to 100,000 astronomical units. And there is the gravitational frontier, the Hill sphere, the edge of the sun's grip itself, the deepest claim of all. And those 4 edges do not sit anywhere near one another. The gap between the innermost of them and the outermost is so enormous that you could lay the entire Sun to Neptune distance, the whole span of the planets, across that gap thousands of times over. The solar system does not have an edge. It has a long, spread-out series of edges, and then, past the last of them, it has a fade. That is the real answer, and it is worth carrying out of tonight and keeping. The true outer boundary of the solar system is not a line, and it is not a surface, and it is not a place. It is a gradient. It is a slow twilight, light years in width, within which the sun's authority hands over to the galaxies so gradually, so smoothly, that there is no moment of crossing at all. No point you could ever mark, no threshold you could ever stand on. Ask where the solar system ends, and the honest answer, the answer the physics actually gives, is that no one can point to the spot. Not because of any lack of knowledge, but because the edge of home is simply not the kind of thing that has a location. So, then, what hides beyond the Oort Cloud? After the whole long journey, we can finally say it plainly, in real things. Beyond the Oort Cloud is the interstellar medium, the galaxy's own thin drifting body of gas and dust, and the solar system is sailing through it, through a small warm cloud, inside a vast supernova-carved bubble, this very moment. Beyond the Oort Cloud are the rogue comets, and very probably the rogue planets, leaked and ejected from every other star system in the galaxy, the drifting cast-off debris of 100 billion other suns, some of which, like Oumuamua, like Borisov, occasionally fall through our own. Beyond the Oort Cloud are the passing stars, Schultz's star in the recent past, brushing the shell while our ancestors watched, Gliese 710 in the deep future, set to pass deep inside it, neighbours close enough to reach in and stir the cloud with their gravity. Beyond the Oort Cloud is the rest of the galaxy, and the deepest single finding of tonight's long journey is that the rest of the galaxy was never truly separate from us at all. The boundary is porous. It always has been. The galaxy reaches in, and the sun's comets leak out, and the edge is a shoreline, and not a wall. There is a particular feeling that comes with all of this, and it is worth naming, because it is not the feeling you might expect. You might expect that learning the solar system has no clean edge, that home fades imperceptibly into the galaxy would feel like a loss, like the walls of the house coming down. It can feel that way for a moment, but sit with it longer and it turns into something else. Because what the night has really shown is not that the solar system is smaller or less real than you thought. It is that the solar system is far larger than you were ever told, and that it is not sealed away from the rest of the universe, behind a wall, but joined to it, continuous with it, part of it. The galaxy is not a separate and distant place you could never reach. The galaxy begins in your own backyard. It begins past the last comet. The interstellar medium that fills the space between the stars is, in a real sense, already lapping at the edges of the heliosphere right now, and the heliosphere is just the solar system's sail, and the solar system is just one small, bright region of a galaxy that goes on, structure within structure, cloud within bubble, as far as anything can see. You do not live in a closed room. You live in an open one, with no far wall, and the rest of the universe is not somewhere else. it is the same room. And consider, too, what it means that this nearest of all frontiers is still uncharted. We sometimes talk as though the age of exploration is over, as though every frontier has been crossed and every map has been filled in, and there is nothing left but to study what we have already found. Tonight is the answer to that. The edge of our own solar system, the place we have spent these hours travelling toward, is not crossed and not mapped. No spacecraft has reached the Oort Cloud. The fastest object human beings have ever launched, Voyager One, sailing outward right now at about 17 kilometers every second, would still need something like 300 years simply to reach the inner edge of the Oort Cloud, and something like 30,000 years to cross to its outer edge. We have not been there. We will not be there for a very long time. The frontier is not behind us. It is ahead of us, and it is close, closer than the nearest star, and it is genuinely, completely open. There is a real chance that within the lifetime of someone listening tonight, the Vera Rubin Observatory and the surveys that follow it will resolve whether Planet 9 is real, will catch interstellar visitors by the dozen, will begin, at last, to draw the first faint lines on the map of the part of the page that nobody has ever drawn. And there is one last thing, the quietest thing, and perhaps the heaviest of all of them. The Oort Cloud, the single largest structure the Sun owns, the shell that defines the entire outer solar system, has never been seen, not once, not by anyone. Every number we have for it is an echo, an inference drawn from the comets that fall out of it into our view. There is, very possibly, a true ninth planet out there, somewhere in that region, that we have simply never found. The outer solar system is, in the most exact and literal sense the word allows, uncharted. Sit with that. We have a map of distant galaxies billions of light years away. We have telescopes that can read the faint, ancient light of the very first stars that ever shone in the universe. And yet the edge of our own solar system, the nearest frontier there is, closer to you than any star, the place where home quietly fades into the galaxy, is still, tonight, mostly dark to us. We have not been there. We have barely begun to look. The unknown, it turns out, was never far away. It does not begin at the next star, or the next galaxy, or the edge of the observable universe. It begins just past the last comet. It has been there your whole life, over your head every single night, just beyond the last drawn ring of the map you were given. And the most honest thing that anyone can tell you about it, the truest thing, is that we have only just begun to look.